Okay, so the last two problems that we're going to go through for one-dimensional forces are number 6 and 7 on the worksheet. So number 6 says a weather balloon exerts an upward force of 98.7 newtons. So the force in the up direction is equal to 98.7 newtons as it lifts a package of instruments totaling 6.5 kilograms. So the mass is equal to 6.5 kilograms. So those are the two basic pieces of information that it gives us. For A, it says what is the acceleration of the weather balloon. So what we need to be careful of here is that we've got multiple forces acting. So the weather balloon is exerting an upward force of 98.7 newtons, but the mass of the package means that we are also going to have a force of gravity, which is the weight of the balloon. In order to figure out the acceleration, we need to figure out what the net force is of the balloon. So the net force is equal to mass times acceleration. So if we want to figure out the acceleration, we know the mass. The mass is 6.5 kilograms, but we need to know the net force. The net force is going to be the sum. So F net is the sum of the upward force and the force of gravity. Okay, so the force of gravity is mass times acceleration due to gravity, so 6.5 times 9.8 meters per second squared. So if we take and figure out the force of gravity, so force of gravity is equal to 6.5 times 9.8, negative 9.8. Negative 9.8. Don't forget that force of gravity is going down. So the force of gravity is equal to negative 63.7 newtons. Negative 63.7 newtons. So now if I plug that into my net force, so F net is equal to my upward force, 98.7 newtons, plus negative 63.7 newtons, gives me a net force of 35.0 newtons. So 35.0 newtons is my net force. My mass is the 6.5 kilograms. So in order to solve for acceleration, I just divide both sides by the mass. So acceleration is equal to 35.0 newtons divided by a mass of 6.5 kilograms, giving me an acceleration of the balloon at 5.4 meters per second squared. Now this answer we are then going to directly use in part B, because part B says if the balloon accelerates from rest, okay, remember from rest means that my initial velocity is going to be 0. So my initial velocity is 0 meters per second. For 10.4 seconds, time is equal to 10.4 seconds, at which point the load of instruments is released. What is the velocity of the instruments at the moment they are released? So what is my final velocity? So final velocity is equal to what? Okay, so my equation for that final velocity is equal to the initial velocity plus acceleration. Okay, so that's the acceleration that I found there, times our time. Well, our initial velocity was 0, so my initial velocity goes away, so my final velocity is just equal to my acceleration, which is 5.4 meters per second squared, times my time, which is 10.4 seconds, giving me a final velocity of approximately 56 meters per second. Okay. So moving on to number 7, it says a woman whose mass at rest is 63 kilograms standing on a pair of bathroom scales in an elevator. Okay, so mass is equal to 63 kilograms. How many kilograms will the scales register as the elevator begins accelerating upwards at a rate of 2.5 meters per second? So the acceleration of the elevator is 2.5 meters per second squared. Okay. Don't forget, acceleration due to gravity is negative 9.8 meters per second squared. Okay. So first we need to figure out what the net force is. So in order to figure out the net force, we have to take the normal force. So the normal force acting on the woman is the opposite of the force of gravity. So we're going to be able to figure that out by calculating what her weight is in terms of newtons, given that her weight is 63 kilograms when at rest. And then we are going to need to add that to the force of the elevator. Okay, so the elevator is providing a force. We know that because it's accelerating. So if it's accelerating, it's providing a force. Gravity is accelerating us in the opposite direction. So in order to figure out the normal force, we have to figure out what the force of gravity is and take the opposite of that. Okay, so let's go ahead and start by figuring out what the force of gravity is, or the normal force on the woman. So the opposite of the force of gravity. So the force of gravity is going to be equal to her mass, 63, times acceleration of negative 9.8 meters per second squared. Okay, so the force of gravity acting on the woman is negative 617.4 newtons, which means that the normal force is the opposite of that. So the normal force is positive 617.4 newtons. Okay, and then we need to add that to the force of the elevator. The force of the elevator is the mass of, so the force of the elevator is the mass of the woman, 63 kilograms, times the acceleration of the elevator, 2.5 meters per second squared. So the force of the force of the elevator is approximately 157.5 newtons. Okay, so 157.5 newtons. So if we add those two together, that will give us the net force. Okay, so the net force, So the net force of the woman is the normal force plus the force of the elevator. So the net force is equal to 617.4 plus 157.5, which gives us 774.9 newtons. So now, in order to get what the elevator thinks is being registered, okay, so in order to get what the scale thinks that the mass of the woman is, we have to take this net force that's acting on it. So remember, force is equal to mass times acceleration. So 774.9 newtons is equal to mass, okay, the mass that the scale thinks that the woman is, times the acceleration. Well, the acceleration that the scale is assuming is 9.8 meters per second squared. It doesn't realize that the elevator is accelerating it in addition. So all it's doing is taking the force that's being applied to it and dividing it by the 9.8 meters per second squared. So if we take 774.9 newtons, divide by 9.8 meters per second squared, we get a mass of 79, approximately 79 kilograms. Okay, so it added an additional 16 kilograms of mass to the woman because of that additional acceleration.